Yeah, I
have a quiz.
I was left behind. I know.
Okay. So.
I'm so ready. So pumped. Able to answer questions and stuff. Yes, questions.
So we are going to do various circuits. We will talk about series, running circuits in series, and running circuits in parallel. Tomorrow, I realize I am an absolute failure at figuring that out.
What?
But I will be able to at least explain to you why I was saying what I was saying.
It's okay, that guy was dumb anyway.
He was literally the radar.
That describes number 12 on the test.
That guy goes from church.
I was like,
Really?
I know this answer. I put it down.
So you can tell him I said you're dumb. Alright.
Okay, so what a schematic diagram is just a fancy way of saying a circuit diagram.
Wait, how do you say it?
Schematic?
Schematic.
Okay, it represents a circuit, and we use different symbols to represent the parts of a particular circuit. And not all of these are exactly how I will do them, but a lot of times you just represent a wire with a simple straight line. Okay, so if here would be an example of a simple circuit. There's a battery. Okay, I've got a resistor here. And it goes back to the battery. Very simple circuit right there. Okay, we use the lines just to represent the wire. This represents a battery. That represents a resistor. I know there is a specific way that we can do a light bulb. A lot of times I will just draw a light bulb like this because a light bulb is a resistor.
Is anything that is powered a resistor, so like a computer?
Anything that resists the flow of electrons would be a resistor.
Exactly.
Which is pretty much everything. Technically a wire
So everything
has a certain amount of resistance, right?
All of it.
So, yeah, don't write zigzags everywhere. We're going to assume that there is no resistance lost in wires. We're also going to assume there's no resistance inside a battery, which we'll talk about today. That are actually, within a battery, there is resistance. And so the voltage at the terminals is not the same as the power source of the battery.
This is actually called a plug.
What else would you call it?
No, I thought there was a better word.
Harpoon? I don't know. You should get right to the chest, right?
Oh, dude, that thing.
60 power pressure.
Boom! So, another thing, I think I showed you this the other day, but you can see a switch. Okay, switch is open, switch is closed. Closed, it will allow current to flow. Open, no current will flow at all. Okay, a regular battery, you could have multiple batteries. Okay, we probably will never use a plug. We'll use light bulbs. We'll use various resistors to explain a few things. This is just kind of giving you some working parts, because we will draw diagrams and use this and try to explain things in series and in parallel this chapter. So just get familiar. Probably as far as what you'll do for homework, anything that's not conceptual, they might ask you to write a circuit diagram that has one light bulb, two light bulbs, and one battery, a switch, and something like that. So if I ask you to write a circuit that had one battery and one resistor and a switch in it, I would just go like this. You could have the switch open or closed, it doesn't matter. But that would be an example of drawing a diagram with one light bulb, one battery, and a switch.
Use and a half.
Okay? Now we will get to far more complicated circuits than this, where we'll have, you know, look at that. Look at those complicated resistors on the back page. Complicated circuits. We'll do complex circuits. Not that.
6? Oh,
It's so complicated.
I'll give you 6 on
Not
that.
that. So, here we go. I've already talked about this. Electric circuit is just anything that has electric components connected, okay, that allows current to flow via the movement of charges, blah, 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 blah. Okay, anything that dissipates energy is called a load. So basically, you could say anything that has resistance is called a load. Like a deuce and a half.
I wrote that extra. Say load, aka.
So a light bulb would be a load. any other resistor with the load. I've kind of already talked about this, so I'll move through this relatively quickly.
Huzzah!
Okay, a closed circuit is one that will not allow current to flow. Okay. An open circuit, current will flow from the terminal, one terminal to another.
Wait, so closed.
Is that opposite? Wait, so closed has path.
Yeah.
Open does not. Oh, in my head you said the opposite.
So this is an open circuit.
Short
Yeah,
circuit
okay,
stuff.
yeah.
The current won't flow in an open circuit.
It's open.
I know you think of, if the door's open, I can go through it. It's not like that.
So confused, like in my
I
head.
guess, I guess when he said
I
that
swear you said opposite with
Yeah,
negative.
yeah, I think you said it doesn't flow with closed.
Well, that's what I thought.
Okay, I didn't mean to, I didn't, no. Well, I
Okay,
guess
I apologize if I said it wrong. Here's the right way of saying it. If it is open, okay, current cannot flow from one terminal to the other. Okay, don't think of it like a door. If a door's open, you can go through it. That's not the case here.
It's like a, you break a path. Like
Yeah, you're breaking the path.
You said that.
It's like a tree falling
If
off.
it is an open circuit, okay, this is open, current cannot flow.
Yeah.
This light bulb will not turn on.
Yeah.
Okay? If I close the switch, it's a closed circuit and will allow current to flow. The light bulb will turn on.
What if it's open on the other side after it's on?
If any part inside is open, it will not flow.
Short circuits have.
Okay, so I could have two switches, and if this one is closed, and then I have another one over here that's open, it still won't
But
flow.
they're really close. But still not that.
I mean, isn't there a
It
gap?
could jump.
Yeah.
Yeah.
That's what I'm getting at.
Yes.
Does alternating current and direct current have different properties?
Yes, we're gonna, in what we're doing today, or in this chapter, we're just doing
Terminal
terminal.
voltage.
Okay, had we got to the next chapter with magnets, because direct current comes as a result of magnets, then we would have talked more about that. Unfortunately, we did not get to the next chapter, which was next chapter.
So could alternating current still power things with an open circuit?
No.
No.
So it's the same idea, you still have to have a closed circuit. It's just, it goes back and forth instead of progressive. Alright, a short circuit, so an example of this is, this was a open circuit and then I touched one end of the battery and then touched here. That would be what we would call a short circuit because it wouldn't be going through a resistor. And so you're basically going from one end of the terminal to the other end of the terminal without any resistance. Okay, and you can imagine how that would be a little bit dangerous. Okay, that's why they have those fuses in the fuse box. Or I guess they don't have fuses anymore, they have circuit breakers. Okay, what the circuit breakers do is they notice an increase, okay, in your current because of the short circuit, and it detects that and shuts it off as immediately as it detects it, just to protect from a lot of current flowing through something really fast, causing it to heat up and do some.
So if you just connect a wire from one end of the battery to another, so you
That's a short circuit?
Yeah, that would do, I mean, it wouldn't explode, but it would get warm really fast.
But that's technically a short circuit.
Yeah, no resistor.
When a wire is like a little bit exposed out the door and you touch it, it shocks you. That's a short circuit.
Well, it would do more than shock you if it was something that was had, you know, if it was like a 120 like household voltage, yeah, that would do some real damage. But if it's like a battery, if it's a battery, it's not gonna do anything. Like you can touch a battery to your tongue to test if a battery's working or not, because 9-volt battery isn't gonna hurt you much. It's just gonna feel like a shock.
Minor poisoning.
No, but it's not like a big shock. It's just like a little bit of a shock. Like a 9-volt won't do much to you, but a 120-volt circuit in your house, that would.
Sure.
Let's see frames look at 9
But
volt.
I find
Like a
something
battery.
plugged in before.
Let's
that.
stick a fork-
Let's
stick a fork in the outlet.
And like,
Yeah.
oh,
I stuck a
wire
key
that
in
it
my
goes out and I
cigarette
stepped on it. It shocked me. That wasn't like.
How'd that go?
Well, maybe
Well, I was
you
holding
were
the
able to get
rubber
out
part of my
fast
key,
enough,
so it didn't shock me at all.
Like you held onto it.
Actually, I stepped on it.
Might have got lucky.
I did it.
Yes.
It's just a load, essentially the same thing.
Yes.
Don't try to kid.
Yep.
What did you have in your?
Don't try to help.
What? I stuck my key in my cigarette lighter.
Yes, what did you have in your hand?
You idiot!
Well, I was holding on to like a rubber part on the key, so it didn't actually shock me. But when I stuck it in, it was like.
So good. Why don't you try to do that in an outlet today?
That's what I said, stick a fork in
Here's
it.
a fork. Scissors. I got my little light bulb that has the closed circle that I put in the electrolyte solution. Do you guys remember that?
Yo, you put that
And like touch the two sides, that would do damage to you. That's a lot. That would like 4 deuces and a half.
What if you
Do you have a
Maybe like
rubber
Bernie's
band
got
on
some
your-
kind of
You don't have the power.
What is 4 deuces? 8?
What?
4 deuces.
A deuce and a half times 4. So 1.5 times 4 is 6.
Deuce and a half.
Alright.
So 6
Let me finish here. We're almost done. I do want to talk about this. Okay. I'm gonna try to make this as simple as possible. It is a little bit more complicated than it may appear. Okay. It says any source of potential difference in electrical energy is called an EMF.
MRE?
EMF.
MRE?
Okay, so a battery would be an EMF. A generator would be a source of an EMF.
What is that? Does that stand for anything?
Electrical
Electrical-
mechanical force.
Electrical motion.
Energy per unit charge.
Ah, that was my second.
No.
What is the
Energy, male, female.
F equals
No, I don't think it is.
F equals per.
Emit, male, female.
Okay. What you can think of an EMF as is a charge pump.
I'll give you a
Okay. Stop. Please stop. Can you do a demonstration?
Think of yourself like fishbowl.
Bella.
In the basement.
Bella.
A man lusting over a banana.
Alright. Now, listen. Anything that transmit non-electrical energy into electrical energy is called an EMF source. So the reason why a battery can be called an EMF source is because of why?
It's a charge pump.
It converts what kind of energy into electrical energy?
Chemical.
Chemical. Is that non-mechanical?
Yeah.
Or non-electrical,
Yes.
excuse me. Yes. Okay? So a battery can be called an EMF source because it transmits non-electrical, which would be, what is the non-electrical energy that a battery uses? Chemical. It takes non-electrical energy and converts it into electrical energy. Okay?
So what happens if there's some things that transmits electric energy? Electric
It's
energy.
It
anti-battery.
wouldn't have to transmit it, it's already in that source.
But yeah, but like, and then it just puts it in the wire, or is that such a thing exists?
I don't think there's, you can't transmit
So we don't actually have
to
any
electrical.
stored electrical energy. We only have.
Well, we could store it with some other source.
Isn't a
Yeah.
capacitor do that?
Like a capacitor would be.
So it's not an EMS though? It's electrical?
I don't know of any situation.
Male,
That's not an EMF. Okay, now, can you let me finish, guys?
Yes.
Okay? Now, in a battery, there is resistance due to what's going on inside a battery. So, if I hook a battery up here, I connect it to a particular wire and put it through a light bulb. Okay? There is a potential difference between this terminal and this terminal. That's known as the terminal voltage. Okay? This battery is called your EMF source. Now be very careful. Technically, there's stuff going on in here where there is resistance. So, the potential difference at these two terminals will always be less than the EMF source. Because inside the battery there is what? resistance. Okay? Is it a huge difference? No. Okay? But here's what I will say. This is how we're going to kind of deal with most things in this. Wow.
Turmoil.
You guys see that with this guys?
I haven't seen any show good. Any other guys?
I've seen it.
Okay? I'm gonna listen. The terminal voltage is going to equal your potential difference and your EMF if, okay, if and only if your
Do we just assume it has no resistance?
yes, for what we're going to do, we are going to assume that the battery has no resistance inside of it, so that the EMF source and the voltage that we're going to use in our diagrams and doing our circuits are the same. But however, could a test question ask you, is the EMF source and the terminal voltage always the same? Is one greater than the other? You should always know that the terminal voltage, or the voltage at the terminals, is always going to be a little bit less than the total EMF source that you have of the battery because of resistance within the what? Battery. Okay? The resistance within the battery is going to make the voltage drop a little bit. Not much, but a little bit.
Which one is left? Yeah, what's that?
Terminal voltage is always going to be less than the EMF.
Nelson knows.
Yeah.
You just left.